Now we proceed to the next topic, discusses about surd. The following are the learning outcomes, and now we consider the following table. Alright, so for all these kind of numbers, okay, all these kind of numbers, if we change to decimal form, we have this column. Alright, so for those numbers, okay, for those numbers that give us irrational numbers, for example, this one, this one, this one, this one, and this one. Okay, that means they are non-repeating and non-terminating numbers. So this kind of number, these numbers are considered, sorry, not this one, but this one. Okay, these numbers are considered as surd. Okay, only those numbers that produce decimal, irrational decimal numbers, so we consider as surd. Okay, now we introduce the anatomy of the radical. Okay, actually this is the anatomy of the radical. So this sign is called radical. All right, so this sign is called a radical. So this sign is called as vinculum, and then this is representing the degree of this radical. So in this following case, we have the seventh root of the given expression, and the expression inside the radical is called as radicand. Alright, so basically all radicals are numbers represented in the following form. Okay, the numbers can be represented in the following form. So if we change this number into decimal numbers or into other numbers, other form of numbers, so we can divide into two classes. The first class is what we call as rational numbers, and the other one is what we call as irrational numbers, as shown in the previous table. So if the outcomes, the decimal point number is of fall under irrational numbers, so we consider that number, this number, as surd. Okay, as surd. So basically a surd is a radical which result at irrational numbers. That means in decimal point numbers, so it is an irrational number, so we call it as surd. So therefore that means not all radicals are surd, but all surds actually are radicals. Alright, so as shown here, all these radicals produce rational numbers. So automatically these numbers are not surd, but all these numbers produce irrational numbers, so all these numbers are considered as surds. So we have some rules of surds. In the first one is related to the multiplication operation of two surds. Okay, so the surd of A times B is equal to the multiplication of surd A and surd B. So it can go forward and also it can go backward. Alright, so same goes with the second one. The surd of A over B is equal to surd A over surd B. And then the third one, A multiply with surd B plus C surd B, because we have a common surd here. So we can factorize, we come up with this expression, A plus C multiply with the surd B. So same goes with the fourth one. The difference is on the operation. We have the subtraction operation. Okay, we also have additional rules. So surd A multiply with surd A, basically it is equal to A over 2 times A over 2. Okay, it is equal to A half plus half equal to A to the power of 1. Alright, and then surd A plus surd A equal to 2 surd A. Surd A divided by surd B is equal to the surd of A over B, and then we have a surd A plus surd B squared. That means if we expand this parenthesis, we are come out with this expression. We have A plus B plus 2 square root of A times B. Okay, and then if we have this kind of situation, we have surd A plus surd B in first parenthesis, while in the second parenthesis we have surd A minus surd B. Okay, we have plus and minus here. We have surd A, we have surd B and surd B. So automatically we know that the outcome is equal to A minus B. So we have a remark here. Remember, okay, so surd A plus B not equal to surd A plus surd B. Okay, not equal to. So same goes with subtraction. Okay, surd A minus B does not equal to surd A minus surd B. Alright. We consider the following example. The question asks you to simplify. Okay, the first one is surd 45. So in this kind of question, to solve this kind of question, we need to factorize the given number to the simplest factors. Okay, for example, square root of 45, we have surd 9 times 5. So we using the surd rule, we can separate, becomes two surds. Surd 9 times surd 5, where surd 9 can be simplified, becomes 3, while 5 remain as surd 5 because that is the simplest form of this number. Surd 5 cannot be factorized anymore. So same goes with the second one. Okay, in the second one we have 5 surd 3 minus surd 27, where surd 27 can be factorized into the simplest form, 9 times 3. So this surd can be separated, becomes surd 9 times surd 3, where surd 9 can be simplified, becomes 3, while surd 3 remains as surd 3. So because we have a common surd here, so we can factorize together, so come out with 5 minus 3, which is equal to 2, and we have surd 3 as the simplest surd from this example. Alright, next is about multiplying radicals. There are two types. Okay, the first one is we multiply two different surds, so we come up with this one. Okay, we multiply the radicand, so come up with this surd. And then the second type is we have A surd B times C surd D. So for this kind of multiplication, we multiply, okay, the number outside the surd together, and we multiply the radicands together and come out with this simple form, AC multiply with the surd B, BD. Okay, now we consider this example. Multiply the following. We have surd 3 times 2 surd 6. Okay, how to solve this problem? Again, 6 can be factorized to 3. So this one, okay. So that means we can multiply. So we have 1 times 2, we have 2. 3 times 6, we have this one equal to 18. And 18 can be further factorized, becomes 9 times 2. That is the simplest factor for 18. Okay. And then we have the surd 9 can be simplified, becomes 3. So we have 6 times surd 2. So 18 also can be factorized, becomes 3 times 6, right? Okay, but if we have 3 times 6, then we have 2 surds as the final answer. We have surd 3 and surd 6 because these two surds cannot be simplified anymore. So we have another option, which is 9 times 2, which can give us only single surd as the final answer. So choose the best one, which can give you the simplest form as the final answer. Alright, now we have 8 surd 2 multiplied in parentheses 5 surd 6 plus surd 2. Alright, so using the rules, so we can expand, we can multiply 8 surd 2 inside the parentheses to both numbers. Okay, we multiply, then we have this equation. Alright, and then using the rules, we can multiply 8 with 5. We can multiply the radicand as well, 2 times 6 and 2 times 2, so come out with this equation. So we have 40 surd 12 plus 8 surd 4. Now 12 can be further factorized, becomes 4 times 3 as the simplest factor. So we have 2 surds here, surd 4, which can be further simplified, becomes 2. We multiply with 40, becomes 80. So surd 3 remain as surd 3 because that is the simplest form, while the other side we have plus 16. So this is supposed to be the final answer lah. Okay. Now we have another one. So we need to expand. Okay, we multiply this one to both elements at the other side, and then we multiply. Okay, so we multiply this one also to both elements at the other side. So we come out with this equation. Okay. So now in this equation, we use all the rules on the surds to simplify this expression. So these radicals can be multiplied, these numbers can be multiplied, these numbers can be multiplied, these radicands also can be multiplied. So come out with this equation. Okay, with this equation. So if we have this kind of situation, we have Z3 times Z3. Actually, we have Z3 square. So the square and the square root can be cancelled out. Okay, can be cancelled out. So the remaining value is 3. So same goes with this one. We have square root square. So this one can cancel out. So the remaining value is 2. So we can simplify this equation, and finally we come out with this simplest form as the final answer. Okay, almost the same question, but this time we have subtraction and addition operation, while the surds are equal in the both parentheses. We have surd 8, surd 8, surd 3, and surd 3. Actually, you can just simply use the rules. Okay, as we learned just now in the previous slides, we have A minus B. So this is the outcome. 8 minus 3, so the outcome is 5. Okay. Alright, so now the task is rationalizing the denominator. Okay, so how to rationalize surd? Okay, suppose we are given this kind of expression. We have 4 plus surd 3. Okay, so to rationalize this surd, okay, this expression, we just need to multiply with the conjugate. Okay, so the conjugate, if the given surd is we have 4 plus 3, so the conjugate is we just simply substitute the operation. If the original equation is plus, so the conjugate is minus. If the original one is minus, so the conjugate is plus. So if we expand together these two parentheses, so we have this equation. Okay, we have this equation. We have 4 square minus 4 surd 3 plus 4 surd 3 minus surd 3 square. So this one can cancel out. We have 3. So clearly here we can rationalize the surd. Okay, means we can eliminate the surd. Alright, so we have minus, we have plus, and we have a common element here. Okay, so this one representing or equal to 0. Okay, so the remaining values are 4 square, which is equal to 16, and 3 surd 3 square equal to 3. So 16 minus 3, the final answer is a natural number or real number 13. So that is to rationalize the surd. Okay, we come up with the conjugate. Okay, now the task, the example is to ask you to rationalize the given expression. So we have 5 over surd 3. Alright, so how to rationalize this one? Because the denominator is surd. Okay, so to rationalize this this expression, we just simply multiply with the conjugate. Okay, so the conjugate is surd 3 over surd 3. Okay, why this equation remain true? Because actually it is equal to 5 over surd 3 we multiply with 1, because surd 3 over surd 3 equal to 1. So that is why the equation remains true. Okay, that means we can proceed. Okay, because this is the multiplication of two fractions, so we just simply multiply the numerator. 5 times surd 3, we have this one, 5 surd 3, and surd 3 square. Okay, surd 3 times surd 3, we have surd 3 square. So we can eliminate this one, square and surd. So the remaining value is 3. Alright, so now we have 5 surd 3 over 3. This is what we call as rationalizing the denominator. Previously, we have surd at the denominator, but as the final answer, we have a non-surd value as the denominator. Alright, now we move to the second one. We have 3 over 2 surd 3. How to rationalize? Again, we have surd 3 as the denominator. So we multiply this fraction with surd 3 over surd 3. The equation remains true because this one is actually equal to 1. So these equations remain true. Okay, so that means we can proceed. So because we have two fractions combined with the multiplication operations, we just simply multiply the numerator and denominator respectively. We start with the multiplication of the numerator, so we have this value, and the multiplication of denominator, we have this value. We can cancel out 2 and surd, so the remaining value is 3. So 2 times 3 equal to 6. Okay, so we have 6 here actually, so which can be further simplified. 3 times 1, 6 times 2, so we have surd 3 over 2. Okay, in any case, when we are dealing with fraction, give your final answer in the simplest form. If you have fraction, so try to give the simplest fraction as the final answer. So instead of give your answer as 3 3 over 6, so simplify this one and come out with the simplest form as the final answer. Okay, how about this one? We have 2 sub 3 over 5 minus sub 3. So what is the conjugate? As I mentioned before, if the original form is minus, so the conjugate is we need to put the additional operation as the conjugate. Alright, so this is the original one. We multiply with the conjugate and the equation remain true because the conjugate, okay, is basically equal to 1. Okay, so we have a multiplication of two fractions. So we just simply multiply the numerator times numerator, denominator times denominator. At the numerator, we have this value. At the denominator, if we expand, so we have this value. So don't forget to simplify. Okay, don't forget to simplify. This one can cancel out. So we have 2 times 3. Okay. And then 25 minus 3 equal to 22. So we have this equation 10 sub 3 plus 6 over 22. And again, simplify or try to give the simplest form as the final answer. Okay, now we move to the next example. The same task, rationalize the denominator and simplify. Alright, so we're given this fraction. We're given this fraction, that means we have a third at the denominator. So we are referring to the denominator to come out with the conjugate value. Okay, not the numerator but denominator. At the denominator we have plus sign, so that means the conjugate we need to use the minus operation atau minus sign. Okay, instead of addition we use subtraction as the conjugate. Okay, so just the same operation because we have two fractions combined with the multiplication operation. So we multiply numerator times numerator, denominator times denominator. Okay, so these two can be cancelled out. Okay, can cancel out because plus minus, okay, equal to 0. So the denominator now becomes, okay, 17 square can cancel out. This one 5 square can be cancel out. So the remaining value is a natural number. Previously, the denominator contains third, but after we rationalize the denominator, the final answer contains natural numbers or real numbers as the denominator. Okay, there is no more third as the denominator. So this is what we call as rationalize the third. Rationalize the denominator. Previously we have third as the final answer. There is no more third as at the denominator. So this is the simplest form. So this one should be the answer. Next, the same almost the same question, but this time we have two fractions with additional operations. So how to solve this problem? So because we have two fractions, okay, with addition operation, we just simply use the ordinary addition of fractions. So because we have different denominator, so we need to come out with similar denominator in order to proceed. So we multiply this side with 1 plus sub 2 and we multiply this side with 1 minus sub 2. Okay, so we have these expressions and we have the denominator equal to 1 minus sub 2 times 1 plus sub 2. Okay, so this is the ordinary fraction operation, addition operation, just like A over B plus C over D. Okay, just same, but this time we're dealing with third. Okay, so we try to simplify this expression. So this one can cancel out. Okay, so the remaining value is 2. So this one we have sub 2, so we have 2 sub 2. Alright, at the other side we have minus sub 2, so we have negative 2 sub 2, and this one also can cancel out, so the remaining value is 2. At the denominator, because we have plus sub 2 minus sub 2, so this one can cancel out because equal to 0, so the remaining value is 1 minus 2. Okay, so this one can cancel out, so that way we have 2. So now we can simplify, we can add all the numbers together, 1 plus 2 plus 1 plus 2, we have 6, okay? So this one can cancel out, we have plus, we have minus, so equal to 0. So the remaining value is 6 over negative 1, which is equal to negative 6. Okay. Now we proceed to the next example. So in this example, the fraction, okay, this fraction contains a third as the denominator. That means we need to rationalize the denominator. So that means we need to use conjugate. So because the denominator contains subtraction operation, so the conjugate must contains addition operation. Okay. So we multiply third 3 minus 2. So the conjugate is third 3 plus 2, third 3 plus 2, which is basically equal to 1. Okay, so now we have two fractions with multiplication operations. So we just simply multiply the numerator together and we multiply the denominator together. So we expand, we have this equation. Okay, we have this equation. So this one can cancel out. Okay, we have third 3 times third 2 also equal to third 2 times third 3. So we have 2, third 3, 2. This one. Okay, becomes this one. And then this one also can cancel out. So we have 2. Okay, at the denominator, so these two can cancel out because we have plus and minus. Okay, just the same third, so we can cancel out. So the remaining values are 3 and 2. 3 and minus 2. So we have this equation. Okay, so now because 3 times 2 equal to 6, okay, we have third 3 times 2 here. Okay, which and then we simplify. This one 3 times 2 equal to 5, equal to 2 third 6. Okay, this one is third 6. Okay, over 1. So we have this equation. We plus with the third 2. So this is the final answer. Okay, instead of using two thirds, so just combine, become single third. So the third 6 cannot be simplified anymore, so it remains as third 6 as the simplest form. Okay, now we move to the next example. The question asks you to solve each of the following equations. Solve means we need to find the answer x equal to what. Okay, that is what the question asks you to do. Solve, that means we need to find what is the value for the x. Okay, so we given third 2x minus 1 minus 5. Okay, where 5 is outside the radical, equal to 0. So now how to solve this problem? We take 5 to the other side. Okay, take to the other side, so we have this expression. Okay, we have 5 at the other side. And then our problem now is the radical sign. So how to cancel out this one? By put the power 2 at both sides. Okay, at both sides. Remember, we need to do on both sides in order to keep the equation remain true. Okay, so we put square here. We also put square at the right side. Okay, so now we can cancel out this one, square and third. Okay, and square root and and to the power of 2. So the remaining value is the radicand, 2x minus 1, and the other side we have 5 square equal to 25. So now it's very easy for us to solve for the x. So x equal to 13. Alright, so the challenging part only here. So the remaining part, I think it's very easy for you to solve. Just use simple algebra. Okay, now we have third 3x plus 1. Okay, outside we have plus 1 equal to x. Okay, I think just using the same strategy. Okay, we put all the value without the radical at the other side. So we put x minus 1 at the right side, and at the left side we have the radical sign. Don't worry, because we still can cancel out by put square at both sides. Okay, we put square so we can cancel out. So the remaining are the radicand value. So at the other side, at right hand side, so we need to expand this one. So we come out with this quadratic equation. So now we need to rearrange this equation until we get the simplest equation. So we have x squared minus 5x equal to 0. Okay, which can be further factorized, becomes x times x minus 5. So we have two possible values for the x. where x could be x equal to 0 or x equal to 5. But that values are not the final answer. Why? Because when we're dealing with surd, we need to check the value for the x, whether the x still can make the given equation valid or not. Okay, so how to do that? So we need to replace the x into the given original expression, and we see whether the equation remain true or not. Okay, first we start with x equal to 0. We replace x equal to 0 to the given equation. So we have, okay, we replace x equal to 0, so we come out with 2 equal to 0, which is obviously not true. Okay, so that means we need to cancel x as the answer. Okay, because when we substitute x equal to 0, this one not becomes equal. So the only remaining value is x equal to 5. So the final answer is x equal to 5. Alright, so remember, when we're dealing with surd, so you need to verify the answer. Okay, the x. Just simply put these two values as your final answer, then maybe you will lose some marks here. Okay. Now we move to the next example. We have surd x plus surd x plus 2 equal to 2. So how to solve this problem? Okay, because we have at the right side we have a non-radical value at the right side. So just simply put square at both sides. Okay, we put square at both sides. So this parenthesis we need to expand. Okay, because we have square, so we need to expand. So we come out with this equation. So okay, so this one can be cancelled out. Okay, so this one can be simplified. Okay, because we have two same expression here, same. So it becomes 2 surd x squared plus 2x. Okay, because the radicand can be multiplied inside. So we have x squared plus 2x. And then this one also can cancel out. So the remaining are the radicand x plus 2, which is equal to 4, comes from 2 square. Okay, now we have a single radical sign here. So we take all the value without the radical to the other side. So we have this expression, and we keep the expression with radical at the left hand side. So now okay, so this one can be further simplified, becomes this, and then 2 also can be this equation also can be further simplified. Okay, becomes this equation. Okay, so now as usual, how to eliminate this radical sign? By put power 2 at the both sides. We put square on the other on the both sides. We put square at the left side. We also put square at the right hand side. So for the left side, we can cancel out this radical form. For the right side, we need to expand. Okay, so expanded one. So we have this equation, and at the other side, we come out with the radicand value, because this one can cancel out. Okay, so there is no more radical sign, so it's very easy for us to solve for x. So we just solve for x. So finally come out with the answer x equal to 1 over 4. Okay, no need to verify because this is the only answer. Okay, next we have surd x plus 13 minus surd 7 minus x equal to 2. All right, so in this solution, we use a different strategy compared to the previous one. So in this solution, we take negative 7 surd 7 minus x to the other side. So we have this equation, and we put square at both sides. Okay, both sides means including 2 in this parenthesis. Okay, so this one easy because we can cancel out, but for the right hand side, we need to expand. Okay, we expand and we come up with this equation. So in this equation, we rearrange until we put the value with radical sign at single side at one side, and put all the value without radical at the other side. Okay, and then we simplify, we come out with this equation. Okay, we simplified, okay, becomes this equation, and then as usual, we put square at both sides. Why? Because we want to eliminate the radical sign. Okay, so we come up with this equation. So this equation can be simplified until we get the value for the x. So we have x equal to -9 and x equal to 3. Because we have two values for the x, we need to check which one is the true solution for this problem. Okay, so how to do that? We need to substitute x into the given expression. Okay, we need to substitute x to the given equation. So let's see which one will give us the true equation. Okay, so we substitute x equal to -9, so it come up with this equation. -2 obviously does not equal to 2, so this is not true. So this one is not the solution. So we try for the x, we put x inside the given expression. Yes, we have 2 equal to 2, which is obviously true. So the solution for this problem is x equal to 3. Okay, we have another question here. We can use almost the same strategy as well. So we put square at both sides. Okay, because we have radicals at both sides, we just simply put square at both sides. Okay, so for the left hand side we need to expand, and for the right hand side we can just simply cancel out, and the remaining value is just the radicand. So at the left hand side we need to expand and then simplify, and then we come out with this equation. Okay, in this equation, again the radicand can be multiplied. Okay, the radicand can be multiplied just like AB. Okay, we just simply multiply A and B, so we come out with this expression. So we take all the value without the radicals to one side. So this time we take to the left hand side, so we have this equation. Okay, and then we simplify, we have this equation. Okay, we simplify lah. Okay, this one, so we come out with this equation. Okay, here our aim is to eliminate the radical sign. So as usual, we put the square. So this one can cancel out. So this expression need to be expanded. So we come out with this quadratic equation, which can be factorized. So we come out with two values for the x equal to half and x equal to -2. Again, because we have two solutions, we need to verify which one is the correct answer. So we just need simply substitute x to the given equation and see which one will give us the true equation. So this one is obviously not true because the third contains negative, so no longer real numbers. This is what we call as complex numbers, so not true. So for the other number, yes, it is true. So we know that x equal to half is the final answer.